Okay, today we are going to look at the product rule. And product, what does that word product mean? Product, multiplication. So we have a checklist when we're multiplying exponents. We look for the base, and we need the like bases, okay? And then we're going to keep the base, and then we're going to add the exponents. So for example, if I have a to the m times a to the n, I look for the base. I have an a and an a, so since they are alike, I keep the a. Then I add the exponents. So I'm going to add the m and the n, so m plus n. Now let's think, why would that work? So I have 2 to the second power, so if I was thinking expanded, I'd be like, well, that's 2 times 2. I need to multiply that times 2 to the fourth power, so 2 to the fourth power, how many more 2's is that? 1, 2, 3, 4. And if I was to go back and add all of this up, 1, 2, 3, 4, 5, 6, I would have 2 to the sixth power. Now, do we want to expand those every time we want to, multiply? No, that would take, just forever, honestly. So how about instead we keep the base and we add the exponent. So we're going to keep the base 2. We're going to add the 2 and the 4, 2 to the sixth. Works the same way with variables, so x to the third, that would be x times x times x times x to the fifth times x, 2, 3, 4, 5. So if we multiplied x to the third times x to the 5 and we expanded that, we would have x 8 times. But we could use our rule and say, well, if I look here, I see I have a like base. I have a common base. I have x. Keeping x, and then I'm going to take those exponents and I'm just going to add them. 3 and 5, add those, I have 8. So let's take a look here at some more numerical expressions. Remember, we're going to keep the base when we're multiplying, and there's that multiplication symbol. Keep that common base of 3, and then we're just going to add the exponent. So 2 plus 4 is 6. I'm going to look here. I have -4 times -4 to the fifth. Common base in multiplication, -4. Add the exponents. Make sure there's not an exponent. Remember, when there's not one, it is 1. So 1 plus 5, 6. 8 to the -4 times 8 to the sixth. Common base is 8. Add the exponents. -4 plus 6, 2. Okay. My next one, 3 to the third times 4 to the third times 3 to the seventh. Look for common like bases. Yeah, I got a 3 and I got a 3. So I have 3 to the, and 3 plus 7, that would be 10. Now what about this 4 to the third? There's only one of those, right? There's only one base that's a 4. So I'm going to say this is 3 to the 10th times 4 to the third. I have 1 to the -5th times 1 to the second. Common base is 1. -5 plus 2. -3. Ooh, 1 to the -3. Can't have a negative in mine. It says up here. Positive exponents. So how would we change that? Remember, we would take it, put it over 1, and then we would move it. So I would have 1 over 1 to the third. Now just think about that. 1 to the third. That's 1 times 1 times 1, right? So that would be 1 over 1. What's 1 divided by 1? Yeah, 1. So when you have a 1 as a base and you have exponents, the only catch is going to be if it's positive or negative. So variable expressions, just like numericals, we look for common bases. A and A, keep the A, add those exponents. Yeah, 5 plus 3 is 8. M, 3 commons, keep the M. I'm going to add all the exponents. What is 4 plus -2? Well, 4 plus negative 2 is 2. And I'm going to take that 2 and I'm going to add it to, well, m to the 1, right? Plus 1. So positive 2 plus 1, that's 3. Common bases in the r's. 4 plus negative 4. R to the 0. Oh, 0 power. Remember? Anything to the 0 power? Just 1. X to the 4th times y times x to the negative 1. Common bases? Yep, that's that x. So 4 plus negative 1 or 4 minus 1 would be 3. Y does not have anything to multiply with, so it just stays y. S times r squared times r to the negative 4 times s. Keep the common bases. Now I know we have an s here. I'm going to start with r, and here's why. We go in alphabetical order. So r and 2 plus negative 4, 2 plus negative 4, well, that's negative 2. And then I have s and s. Now if I multiply those, how many s's are there? Yep, there's 2. Remember that magic 1 there that we don't see? 1 and 1 makes 2. Now there's a negative in my powers, and I can't have that. So if I set this up over 1, the negative has to move. Positive stays, negative moves. So s squared is still on top of the fraction or in the numerator, and r squared moves to the denominator and becomes positive because we have divided across that fraction line. Okay, one more. This is your challenge. Pause the video, try it for yourself, and then come back and check. All right. Did you have 5 to the 4th, a to the 7th, b to the 5th, c to the 0, and d to the negative 2? So remember, you have to go through and find which ones are alike and then add those exponents. And I see I have some things here that I need to change up because c to the 0, well, c to the 0, that's just saying times 1. So I don't need the c to the 0. And then I have this d to the negative 2. Cannot have that negative exponent. So I'm going to set this up as a fraction so that I can move across, I can divide out across this fraction bar and put the d to the 2nd in the denominator. So I'm going to keep this. I have 5 to the 4th, a to the 7th, b to the 5th, over d to the 2nd. Now if they're simplifying, they would actually take the 5 to the 4th, and 5 to the 4th is like 25 times 25. So that's 625. A to the 7th, b to the 5th, over d squared. So remember, keep the like bases. Add your exponents.